Lesson 59 is on rearranging before substitution. Now in Lesson 4 we learned about what simultaneous equations were and how to solve those using substitution. Remember, simultaneous equations, what we're doing right now anyway, they're linear equations, and when we solve for them, we're solving for where they intersect. And so there's an XY ordered pair that we're solving for. The difference in this lesson and the previous one is that now we need to rearrange so that we can do our substitution appropriately. Like, look at practice problem A. We have x minus 2y equals 9 and 2x minus 3y equals 5. Well, we can't really substitute anything from the first equation into the second one yet. We need to get it in the proper form first. And we need to just pick one of those two equations to rearrange first, and then we'll substitute. So the top one, that would be easier to do because it's already got an x variable just by itself, and that's what we want to do in order to substitute. So let's just rearrange that top one, and we can do that in our head. We would add 2y to both sides, and we end up with x equals 2y plus 9. Now that we've rearranged it, we can see that we could take that 2y plus 9 and put that in where x is in the second equation. That's how we solve these simultaneous equations, is by substitution. We can do this substitution because those are equal relationships. X equals 2y plus 9. We're saying that's what x equals, and so we can put it in there for x in the second equation. It's just another way of representing x. So now we can say 2 parentheses 2y plus 9 minus 3y is equal to 5. Then we can go ahead and simplify that. 2 times 2y is 4y plus 2 times 9 is 18 minus 3y is equal to 5. And so we can add like terms on the left, and we'll end up with just y plus 18 is equal to 5. And then we could subtract 18 from both sides there, and we would end up with y equals negative 13. So we have the y value for this ordered pair. We need the x value still. So we'll go back in to that equation that we rearranged, and we can solve for x because it's already set equal to x. So we can say x equals 2 times negative 13 plus 9. And so that would be a negative 26 plus 9. And so that would be equal to negative 17. We want to write our answer as an ordered pair, and so we write it negative 17, comma, negative 13. X, comma, y. That's always how you write ordered pairs. X first, y second. So these simultaneous equations, they're just a little more complex than the ones you've been doing, only because you just have to rearrange one of the two equations first. You set it equal to x or equal to y and substitute it in to the second one to solve for your ordered pair. Let's do one more of these. Look at practice problem B. Solve that system of equations there, simultaneous equations. And usually in the textbook they'll put a brace around it to remind you that these are simultaneous equations. They're two lines, and you're solving for where they intersect, that point of intersection. Now we look at those two equations, and both of them have a y variable by itself, but we would need to rearrange them in order to get it just on one side of the equal sign. And the top one would be easier to do because it's a positive y. So let's just go ahead and rearrange the top equation there. And we would do that by adding a negative 3x to both sides. We can just do that in our head, and we know that we would come up with y equals negative 3x plus 18. So that value there, we would take that and substitute it in for y in that second equation. So let's go ahead and do that next. 2x minus parentheses negative 3x plus 18 is equal to 2. Now we go ahead and simplify this. 2x minus a negative, that would be plus 3x, and then minus a positive 18 would be negative 18 equals 2. Add the like terms. 5x minus 18 equals 2. Then we need to add 18 to both sides. That cancels on the left, and we have 5x is equal to 20. And now we just have to think 5 times 4 equals 20, so x is equal to 4. Now we need to figure out what y is, so let's go back and substitute it into that original equation that we rearranged. And I'll do this right over to the right of where I have it circled in blue. Minus 3 times 4 plus 18. That would be a minus 12 plus 18, or 6. So y is equal to 6. Let's write our ordered pair, 4, 6. Now, if we were to rearrange both of those equations and set them equal to just y, plot some points for them on a number line, or not on a number line, on a Cartesian coordinate system, we would see that they would intersect at 4, 6. Okay, well that's all for lesson 59.